Hi guys, welcome along to lesson 16. Well, it's not really a lesson, but it's the last lesson, if you like, in the tutorial series on my basic programming for computers. Right, this lesson's a little bit different, as I mentioned in the description on the site. We're just going to go with some thoughts on this one, so I sort of expect you to look back on the lessons you've learned and sort of go forward from there, improve your programming knowledge, etc., etc. One thing I mentioned in there looking forward was a chess game based on matrices. This is an array B. Okay, I'll give you the legend and X. We're looking here at a simple layout for what you'll become aware of in a moment, noughts and crosses, or tic-tac-toe as you call it in America. X will equal -1. A space would be equal to 0. I've put a line through the 0 so you can differentiate that from an O. And O would equal 1. So these are your numerical values would be -1, 0 and 1, okay, which are in the matrix there. So B is assigned 3, 3, not B9 as we've used in the past. 3, 3 is simply 3 across, 3 down. Okay, so we've got 3 numbers across, 3 numbers down. It's what we call a two-dimensional array. Okay, as I mentioned, we could, if we wanted to improve that, if we want to increase that for such as a chessboard or something like that, we would then have B as 8, 8, where we would have 8 values across, 8 down, and we could move the pieces accordingly in any area of B we would let. For instance, if we moved a variable, if we moved a piece from there to there on the chessboard, we would simply let B 2, 2 equal B 1, 1, and then we'd 0 B 1, 1, because of course that would then make sure that it would print out a blank space on the board with your print routine. I would suggest that you have a print routine that looks at the board's values and prints out whatever you let these values mean. So in other words, if -1 is an X, which it is there, and 1 is an O, then it prints out an X there, an O there, and of course the 0, it will print out a space which is there. So that's how we're working this system. So we've got here B is 3, 3. It's just a simple idea to get you going. I'm not going to do a program for this because it would be far too involved. I could do one, but it would take me hours and hours, and I think you'd probably get bored by the time we went through the whole program and give you the rundown of how it works, etc. So I'll leave it to you to try your own methods. Trial and error is a very, very good way of learning when you're programming. But just to give you a few pointers on this, the reason why I'm using -1 and 1 and not, say, 1 and 2 is because they nicely cancel each other out. Let me give you an example. First of all, when a player or the computer, assuming you're playing you're playing with the computer, makes a move, you check to see if there's a win situation. So it's easier to check if, for instance, shall we say B 1, 1, B 2, 1, and B 3, 1. If we add those values together, what do we get? We get a 0, because -1 plus 1, well, -1 plus 0 plus 1 equals 0. So in that situation we haven't got a win. We can only get a win if those 3 positions are equal to either 3 or -3 when they're added together. In other words, if we had 3 x's in a row, there's x -1, so we'd have -1 there, -1 there, -1 there. -1 plus -1 plus -1 would equal -3. That would give us a win situation. And similarly, of course, if we had 3 O's in a row, where O equals 1, we would have 1, 1 and 1. Well, 1 plus 1 plus 1 equals 3. So therefore we have a win on either 3 or -3. It makes it a lot easier to try and work out for your maths how you're going to get a winner. And by the same token, we can decide where we're going to put the next move if we're deciding for the computer. For instance, if we have, like we have a scenario here, -1 and 1, so we would look at that and we'd say no, there can't possibly be a win on there, because we're looking for either, if the computer's -1, if the computer's playing X, we're looking for a -2 with a blank space, or we're looking for 2 if the computer's O with a blank space. None of those situations occur there because it equals 0, so we can't possibly have a win move from there. We could look down this row, and I just undo that, I just caught the mouse there. We can look down here and we can see that -1 plus 1 is 0, -1 is -1. So from -1, although there actually isn't a blank space there, but a -1 still can't give us a move, a winning move anyway. And similarly for the other two, where we've got these cancel each other out, so we've got 0 across there, we've got 0 across there, 0 across there, 0 across there, we've got 1 down there, so we can't possibly win on that situation. The best one we can do is this one, where we can have, we've got -1 plus -1 plus 0 is -2, and the third space is a 0, so therefore if it's X's move, then X would put 1 in there and give it a full give it a win situation. Let me just briefly show you that. We'll just get rid of that. Sorry about my drawing on these guys. I'm not very good at drawing with a mouse, as you've probably gathered, but I'm sure you get the idea, and I'm sure you get a laugh at the situation. And where are we? That one there. And I don't know why this is not coming down. It is. What was coming down? Let me see if I can get that down a bit more. Okay. So we've got -1 there. Oh, actually, I didn't want that one. I wanted that one. Okay. -1 there, -1 there, and -1 there, which gives us a row there. To make this a little bit easier for you to see, you can just imagine that this is your noughts and crosses board there, which is still your array. Obviously you would put your array in there as such. Sorry, it's not a very good drawing, but I'm sure you get the idea. And that's how you would go roundabout programming, or the idea of programming for a noughts and crosses. So I hope that gives you some good ideas there. You would use a similar system if you were doing, for instance, well, I've already mentioned chess. You'd do an 8x8 if you were doing, for instance, noughts and crosses, snakes and ladders, or something like that. You'd do a 10x10 array. You can use this system for mazes, where you could do maybe a 20x20, and you can have a path that goes through the maze. So they would decide that way you can't go that way. You decide this in your program, but you could go that way, for instance. You can't go that way, but you can go that way, and make yourself a little path in a maze. You would use a matrix for that. Excuse me. That's another good example. Of course, for designing crosswords, it's another good example where every little square would be a position on your matrix. One thing to remember is a matrix doesn't have to have numbers in, but if you have a matrix that has characters in it, i.e. letters, you would need to have the $sign after it, so that would need to be $. But you would dimension it the same dimension, $, bracket 3, 3, or however many characters you were going to use in that particular array. And the same with the number. You would just dim this one, for instance, it's B 3, 3. So you would have to dimension. You have to dimension these in a dim statement at the beginning of your program, so the computer knows to allow enough memory for it, and that you can access it. Well, as I said earlier on, we've come to the end of this set of tutorials. I hope you've enjoyed them. I hope you've learned something from them. It's been a pleasure teaching you. I hope you go out there and do marvellous with it. I hope you really stick it out and do more. I may do some more in the future, but nothing's decided yet. I'll see how we go on that. So all being well, if you've liked these videos, please rate and favourite them. And if you like our channel, please subscribe to the channel. I'll put the link to this tutorial in the description, and I'll put the link to our website in there. Please visit our website. We've got lots and lots of useful tips, hints, tips, tutorials, all sorts on there. We'd love to see you on there. We'd love to see you visitors. So thanks for watching, guys. Take care, and bye for now.